Hey everybody, it's Mr. McComb for some math work here today. Hope you're off to a good start this week. This is our next part of the puzzle here as far as dividing decimals. Hopefully you found the first video with Mr. Wara informative and helpful as we get in. Now we're actually going to be solving these problems. I'm actually going to start on page 311 where you should have gotten through yesterday. I think up to yesterday you had up to number 8 here. We see down below. I'm going to go through 3, 4, and 5 and go through these real quick. Again, now we're doing long division where we're actually solving and finding answers. I am going to show a couple examples. These are 3 great examples to get us started. Again, hopefully you did this yesterday, and this is going to be to go over and check, okay, and then that'll lead you into what you're going to get done today. These are good ones to look at as far as, again, dividing decimals by whole numbers to get us warmed up for all the good things we're going to do with this stuff, okay? So big thing with this, if we're basically, when we're dividing with whole numbers, easy way to think of that decimal point is we're just going to go ahead and put a decimal point or a quotient right above where we started with that answer there, okay? So here I'm doing $8.24 divided by 8. And we're just going to go through and, again, use this as a way to check on the long division process and then how we incorporate the decimals. Basically, once we place this decimal here, as long as everything's lined up nicely, we can just basically treat it like whole number division, like 824 divided by 8. As long as we put things where they need to go, we're going to be fine there, okay? So if I'm looking at this guy, I'm going to see how many times is 8 going to 8, and of course that's going to be 1. I'm going to put a 1 here, and 8 times 1 would be 8, so I'm going to try to draw this in, and then we would subtract, and we'd have 0, okay? And then, of course, the way the process works, we're going to bring down our 2. Now, this one is a good way to look at because we've got 2. How many times would 8 go into 2 is 0, so that means we need to place a 0 above our 2. So again, remember that little detail as we go through. Sorry, I'm trying to draw with this thing. I'm not so great at it yet. There's a little better. Okay, so then what we can do is bring down our 4, and we're going to think, okay, how many times is, well, now we got 24. How many times is 8 going to go into 24? So, hey, we know what that is. It's 3, right? 8 times 3 would be exactly 24. So we're going to subtract 24, and we've got 0 left over. I think for this lesson, everything's going to work out nicely without having to worry about any remainders. We'll get into that yucky stuff when there's extra stuff happening later on, but for now, we're good. Again, since this is money, put a $sign. Okay, so first one, again, just doing long division right now, okay? Next one, okay, this is a good one to look at because we have 2 and 5200ths divided by 3. So in this case, our divisor is actually larger than our dividend, okay? So you want to make sure with this one, we're going to place that decimal point right above where it is in the dividend. And here we'd say how many times is 3 going to 2 would be 0. So we do want to place a 0 here to mean we have 0 whole parts. Then we can look at it as how many times will we go into 25? How many times would 3 go into 25? And again, just kind of reviewing our facts, multiplication facts, we can say, well, we know that it'll go in 8 times. Can get me close. And that would be 24. So then we'll subtract. And when we subtract there, we got 1. And then again, just to review the process, we'll bring down our 2. So we're trying to see how many times will 3 go into 12. And then we can think, all right, well, that's going to be 4 times, which would be exactly 12, which would subtract out and have 0 left over. So here our answer, 2 and 5200ths divided by 3 would be 0 and 8400ths, okay? Then we get to number 5. 5 is a little bit troublesome or a little bit tougher than these other two. When we're looking at the first 3 and 4 numbers, we got dividing by 8 and dividing by 3. We really just have to think of our 3 facts, and that's not too difficult. But with this one, we've got dividing by 27, and that's kind of a little bit more difficult. So what I want to do with this, I put a spot up here just like we did in our last lesson with estimating quotients. And I'm going to show you here how estimating a quotient can get you started off on the right place, okay? So with this one, if I was to do that estimating the quotient stuff we'd done in our last lesson, if I'm looking at dividing by 27, I'd like to probably round that up to 30. I'm going to make this a little bigger to see. I'm going to make that a 30. Think of it like dividing by 30. And then if I do a compatible number with that, I might change my 97 to a 90. And then we can do some quick and easy estimation with that. We got zeros here. So again, thinking about those powers and patterns with tens, if I'm dividing by zeros, I can cancel those out, those powers of 10. And then I'm left with a very basic fact of 90 divided by 3 would, of course, be 3. And so there we can see an estimated answer, and let's take a look at how we can use that to help us out with starting off to answer our question, or to actually solve this problem. Okay, so here we're going to do we're going to place that decimal there. Now we can't go 27 can't go into 9, and then you got to think, how many times did 27 go into 97? Now even for me that's kind of hard to think of, because it's not like 27s aren't facts, I know, but if I use this estimated answer of 3, that can get me started. If I know my answer is going to be around 3, but based on my estimate, I can actually start with that and see if that's going to work out. So if I try to do 27 times 3 off to the side, maybe I'm thinking, okay, my estimate tells me it's probably going to be around 3. So let me just check and see. 7 times 3 is 21. 3 times 2 is 6, plus 1 more is, or sorry, plus 2 more is going to be 8. So 27 times 3 is 81. So now we can say, all right, well, I found out that I can get up to 81. Now I might think, could I get another group of 27 to go up to be less than 97? And the answer is no, I can't. So what I can actually do here is I can say, all right, well, I just found out we can do 3 groups of 27, which is going to be 81. Really bad with the 8s on this. And if we subtract that out, I get 16. And then I can keep going. Now, another thing we did when we were doing division with whole numbers and larger whole numbers is to use that as a way to check. Here I have 16, which is less than 27, which means I can't get another group of 27. That's another way for me to check and know that I'm on the right track. And then I'm going to bring down my 2 here. Now I need to think, how many times is 27 going to go into 162? The answer with that one, you might think, okay, if I look at what I've got here is 81, I could double that, and that actually is going to help me out a lot. You could try 27 times 4, 27 times 5. I'm actually going to go right into 27 times 6. We're going to see that is 7 times 6, 42. 6 times 2 is 12, and 4 more is 162. So this is going to give us the number we're looking for, okay? So here we're going to have a 6 go in here. And we're going to subtract 162. We got 0 left over. So there we found our answer. Again, when we get into ones like this, again, the estimate is good and helpful to help us get close and know about where we're going to need to be to begin. And then we might get into situations like I did over here. I just worked out. Again, you might try 27 times 5 and then realize you can do another group of 27 to make 27 times 6 would be what we want, okay? So again, sometimes we'll get situations like this where we got to work through it a little bit, use some of those skills we know to help us out, okay? So you should have had up to number 8 done yesterday, and then now you're continuing on with 9, 10, and 11. And then the rest of this page I said don't do 12 through 14. I'm just going to make things a little easier on us and just skip those. I do want to look at 15 and 16 real quick. I kind of set these up here for us ahead of time to talk through. So if you want to go down to 15 and 16 just to preview, number 15 has this problem. It says May runs 80 and 85 hundredths miles in 3 weeks, and if she runs 5 days each week, what is the average distance she runs each day? This one's a little tricky because we need to think how much am I dividing by? We know our total distance is 80 and 85 hundredths, but we're not going to divide by 3, and we're not going to divide by 5 either. What they tell us is this is over the course of 3 weeks, and each of those 3 weeks she runs 5 days each week. So what we need to actually do is think, how many total days are we talking about here to get to these total miles? And that would mean 5 times 3 is going to tell us what we need to end up dividing by. And of course, 5 times 3 is going to be 15. Okay, so just to set this up for you, we're going to divide that number by 15. Okay, so we're going to do 80 and 85 hundredths divided by 15. All right, and then if we go to number 16, again, I'm just kind of going through this to help you set up. This one says Rob buys 6 tickets to the basketball game and he pays $8.50 for parking. So his total cost is $40.54. That includes the parking and the ticket. So our question is, what is the cost of each ticket? So for this one, what we want to do is actually we need to subtract out the cost of the parking amounts first. So we take our total minus the parking is going to tell us how much he paid for the tickets. And then when we get an answer there, I'm going to take this answer we get when you subtract, and then you're going to put that into your dividend to divide by. Okay, so again, a little clue for you. This is a two-step problem. Take this difference here, and then that's how much the tickets cost. And if there's 6 of them, we can divide to find how much each ticket costs. Okay, so there we get into some multi-step problems. Okay, I'm going to real quick go to the next page and look at this one. This unlocked the problem. Here we have a situation where we have different widths of lanes in a swimming pool, and I've kind of set this up. This is another multi-step problem here. It says the standard width of 8 lanes in swimming pools used for competitions is 21 and 92 meters. So 8 lanes, 21 and 92 and then the standard width of 9 lanes is 21 and 96 hundredths. So they're telling us 2 different amounts. And the question is, how much wider is each lane when there are 8 lanes and when there are 9? So a couple things here. When it's asking us, what are we asked to find? We say we need to find the difference between the 2 lanes. Now, what operations are we going to use to solve the problem? Now, first of all, we need to use division, okay? We will use division, but we're also going to use another operation, which if we're going to find the difference between 2 answers, we're going to find those quotients, and then we're going to use subtraction to find the difference, which will be our final answer. All right, so again, just going through this one with you, making sure we're all set up nicely. So I've actually written out step 1, step 2, and step 3. Okay, so these are, make sure you look to this when you get to this point. You got to pause and go back in the video. That's great. But we're going to take the 8 lane size divided by 8 lanes. That'll tell us how much one of those lanes is when it's 8 lanes. And then we take the 9 lanes, the size of the whole thing divided by how many there are, which is 9. So we need to solve these 2 problems. And then step 3, we're going to take those quotients and subtract to find the difference, which will be our final answer. This is a multi-step problem here. We have to find the 2 widths and then be able to subtract to find the difference. So keep in mind there, we're going to do our subtracting of decimals, so line up those decimal points. Don't forget that important skill that we spent so much time on earlier in the year. And then in here, we're just going to tell those answers. So each lane is blank meters wide when there are 8 lanes. Each lane is blank when there are 9. Then we subtract, and then we see that one is this much wider than the other. Okay. Other than that, 18 and 19 shouldn't be too much trouble. I did set up number 19. That's another one where we're going to divide by a divisor that's larger than the dividend. So we should have a number less than 1 for our answer. So I actually started off, if we set this up, we'd see, okay, I can't get a group of 16 from 14, so I should actually look at like a 142, which means I got 0 for my whole number there. Okay, so just kind of start that off for you. I would advise you to go back and look at this as you work through. Just kind of keep this video up and go through each part as you get to it. Good luck with it. Tomorrow you're going to get into the homework, and then we'll do the mid-chapter checkpoint. Just some good practice here. Again, freshen up on the long division. Everything should work out nicely for us as we get into this dividing decimals by whole numbers. Good luck, guys. I'll see you soon back here on the YouTube videos, and always available to talk to you on our chats now, and we'll try to set that up and get you those resources if you need it to. Okay. Good luck. Thanks. Bye-bye.